friends, welcome to our channel Civil Friendly, a platform we chose to share our knowledge on civil engineering subjects. This lecture series is about fluid mechanics, a subject which is important both academically and in exam point of view. And in each lecture, we try to explain the subject in parts starting with properties of fluids. Let me try explaining it in an easy and interesting way. Now let's get into the lecture. Basically, what is a fluid? A substance that flows is called as fluid, which includes both liquids and gases. So the study of behavior of fluids at rest as well as in motion is called mechanics of fluid. So the study of fluids at rest is called fluid statics. The study of fluids in motion where the pressure force is not considered is called fluid kinematics, and the study of fluids in motion where the pressure force is considered it's called fluid dynamics. The examples of fluids are water, oil, fuel, compressed gas, etc. Each fluid has its own properties. So the real life applications, some of which I listed below are: first one is hydraulic machines. Example, turbines and pumps. Second one, hydraulic jack, in which the pressure of the fluid is used as the lifting potential. Third one, lubricants. Example, oils. Fourth is power generation, example hydroelectric power station, and fifth one is fuels, example petrol, diesel, etc. There are many more applications than this, and basic question is why we have to study this fluid mechanics. So to explore the potential of the fluid, to choose the right fluid, that is for lubrication we use this oil or this type of oil, we have to choose the right fluid, and I am saying that for an example. And to handle it wisely means we have to harness the maximum energy out of it. To achieve that, we have to know the properties and behavior of fluids at different conditions. So fluid mechanics explains certain definitions, formulas, conditions and derivations that explain the state of fluid and its behavior. So basically there are 8 properties of fluids, starting from mass density, specific weight, specific volume, specific gravity, viscosity, compressibility, capillarity and surface tension. We are going to discuss these 8 properties, starting with mass density. So the density of the fluid is the ratio of mass of the fluid to its volume. That is the amount of mass contained in a certain volume. It is represented as rho. So rho is equal to mass of fluid by volume of fluid. Its unit is kilogram per meter cube in SI units, or gram per centimeter cube in CGS system, or metric slug per meter cube in MKS system. So the dimension is ml per minus 3. This m is for the mass, kilogram, and this l is for the length, that is meters. So the points to be noted here are: density of water is 1000 kg per meter cube or 1 gram per cc. And the density of liquid may be considered constant, that is the variation of density of liquid is minimum, but the density of gases changes rapidly with the variations in pressure and temperature. For example, if the pressure increases, density of gases increases, and if the temperature increases, the density of gases decreases. So the next property is specific weight. It can also be mentioned as unit weight or weight density. So weight density is the ratio between weight of fluid to its volume. That is the weight in certain amount of volume we are considering. So gamma is equal to W by V. This W we can write as mass into gravitational force, and this M by V we are taking that as rho, which is mass density. So gamma is equal to rho into G. So its units are kilogram for mass, meter per second square for this gravitational force, and meter cube for this volume. So this whole term, kilogram meter per second square, can be written as Newton. So its unit is Newton per meter cube in SI units. Likewise, we can write gram centimeter per second square by the whole divided by centimeter cube. So this whole term gram centimeter per second square can be written as dyne. So the whole unit is dyne per centimeter cube in CGS system. And again metric slug meter per second square, the whole divided by meter cube. This metric slug meter per second square can be written as kgf. So the whole unit is kgf per meter cube in MKS system. So the dimension of this property, that is specific weight, is, so for this kilogram we can write a m, that is mass, and for this meter we can write a L, that is length. For this second square we can write T square, that is time, and for this meter cube we can write L cube, that is L for length. So cancelling we get m L power minus 2 T power minus 2. So the point to be noted here is unit weight of water is 9.81 kilonewton per meter cube. The next property is specific volume. Specific volume is the ratio of volume of fluid to the mass of the fluid. That is, you can see here the denominator has mass and the numerator has volume, which is an inverse of the mass density we studied first. So it can be written as 1 by rho, and its unit is meter cube per kilogram, and the dimension is m power minus 1 L power 3. The fourth property is specific gravity or relative density. It is defined as the ratio of weight density or mass density. We can either consider, we are going to compare the weight density or the mass density of fluid to any standard liquid. So for liquids, standard fluid is considered as water. For gases, standard fluid is air. So here you can understand the specific gravity S is equal to weight density of liquid by weight density of water. This can otherwise be written as normally mass density of liquid by mass density of water. That is also correct. So to find the weight density of liquid, we can cross multiply this. So S into weight density of water. For weight density of water we already know 9.81 kilonewton per meter cube. And the density of liquid is equal to specific gravity into density of water, which is 1000 kilogram per meter cube. The points to be noted here are specific gravity of oil is 0.8, specific gravity of mercury is 13.6, and density of mercury is 13,600 kilogram per meter cube, which is obtained by multiplying the specific gravity of mercury, that is 13.6, into the density of water, that is 13.6 into 1000. Here 13. Okay, 13.6 into 1000, we get 13,600 kilogram per meter cube. So now let us see an example. Calculate the specific weight, density and specific gravity of 1 liter of liquid which weighs 9 Newton. They have given the volume as 1 liter and the weight is 9 Newton. So we already know specific weight is equal to weight by volume. So this volume we are converting from liters to meter cube. So we get 10 power minus 3 meter cube, and here specific weight is equal to 9 divided by 10 power minus 3, which is equal to 9000 Newton per meter cube. When this converted to kilonewton, it is 9 kilonewton per meter cube. Density, we already know weight is equal to density into gravitational force. So density is equal to weight by gravitational force. Weight we found that as 9000 Newton per meter cube divided by 9.81. Its unit is kilogram per meter cube. We get density as 917.43 kilogram per meter cube, and specific gravity, which is density of liquid by density of water. We found density of liquid as 917.43 and density of water we know that as 1000 kilogram per meter cube. So by dividing we get S is equal to 0.9174. Here the specific gravity doesn't have a unit because it's a ratio of both terms. The both terms are equal, that is the density divided by density. So the units get cancelled. So the specific gravity doesn't have an unit. The other properties we can continue in the next video, and hope you found this video useful. Please share it with your friends, and if there is any doubt or any corrections or suggestions, please do mention in the comment section below. Thank you.